Hello, Assalamualaikum. Nama saya Muhammad Farid bin Nazri. Kami daripada grup 8. Hari ini saya nak bentangkan pasal group project, summarize our understanding about subject programmable logic control ni. Kami daripada grup 8. Ketuanya Muhammad Haikal bin Halim. Lepas tu selebihnya saya Muhammad Farid dan Putri Nazatul Iman. Hari ini saya nak summarize. Kalau saya adalah summarize daripada week 1 sampai week 5. Kalau Haikal daripada week 6 sampai ke week 9. Dan Putri pula daripada week 10 ke week 14. Ini adalah aktiviti yang kita dah buat daripada minggu pertama sampai minggu kelima. Minggu pertama kita belajar, kita dengar talk PLC pneumatic and hydraulic application talks. Minggu kedua PLC course activity on previous semester. Minggu ketiga introduction for the first chapter pertama untuk semester ni, dan pre-lab activities of learning sebab kita tak boleh masuk lab kan. Lepas tu minggu keempat pre-lab activity juga, tapi ini kita bincang dengan pre-lab activity yang minggu ketiga tu. Lepas tu minggu kelima tu learning about the basic ladder diagram, basic logic instruction dia, lepas tu basic logic function. For the first week kita belajar pasal kita dengar talk daripada speaker ni adalah Encik Azhar. Dia adalah sales engineer. Industrial talk ni start 29 Mac 2021 pada pukul 9 malam 9 pagi guna Zoom meeting. Encik Azhar ni bagi talk about PLC, pneumatic and hydraulic application. Kiranya dia share dia punya experience dengan knowledge kepada kita. Kira pengalaman dia mengenai semua bidang-bidang ni yang melibatkan dalam industri. Knowledge about the advantage using the pneumatic and hydraulic system. Kiranya dua-dua ni ada effect and safety macam mana, kiranya cara nak penjagaan dua sistem ni. Contohnya lah, kalau hydraulic we know dia punya sistem dia macam mana dan bagaimana cara proses benda ni berlaku. Kiranya hydraulic ni hydraulic dengan pneumatic ni kita boleh tahu apa beza antara dua tu macam mana dari segi safety, daripada segi cara maintenance dia, lepas tu dari segi costing dia. Lepas tu Encik Azhar juga bagi kita info about the programmable logic control PLC and the component of PLC. Kiranya info macam mana PLC tu works dalam industri dan apa current industri sekarang yang guna sistem PLC ni. Kiranya PLC juga macam dah guna dalam pneumatic system lah. Contohnya dari sistem-sistem yang kilang-kilang yang melibatkan conveyor belt semua tu kan menggunakan PLC. So dari situlah kita boleh tahu yang PLC ni sangat berkait rapat dengan industri sekarang. Ini table content ada 4. What is PLC and how it works? PLC ni macam dia adalah satu programmable controller yang industrial digital computer which has been ruggedized and adapted for the control and manufacturing process, which is in assembly line lah, which are robotic device or activity yang require high reliability yang is to the programming and process the fault. programmable logic control is used in semua industrial automation. Kiranya dia specify satu proses tu yang melibatkan semua entirely machine function. Okay, what is hydraulic and pneumatic? Hydraulic is what is hydraulic and pneumatic? Okay, hydraulic ni dia more kepada fluid, dan kiranya fluid power lah. They are use pressurized fluid yang digunakan. Lepas tu kalau pneumatic more kepada gas, more to gas, which is pressurized pressure. Dua-dua ni semua guna dalam industri moden sampai sekarang. Okay, advantage between hydraulic and pneumatic system. Okay, advantage of hydraulic, basically hydraulic lagi safe, lagi senang untuk maintain. Lepas tu dia punya liquid tu tak absorb dengan mana-mana supply energy. Lepas tu dengan simple push start button, hydraulic tu boleh control. Okay, kalau untuk pneumatic, dia bergantung kepada udara, air. Lepas tu the compressibility of air, dengan maintenance dia lebih murah daripada hydraulic. Also dia lebih daripada segi safety tu, dia lagi selamat lah dari segi kebakaran semua. Lepas tu sangat reliable daripada segi controlling remote controlling. Okay, aplikasi yang sekarang guna dalam sistem yang menggunakan PLC lah kan. Okay, macam kita tahu tadi, PLC ialah microprocessor yang continuously monitor the state of input and device process. Macam dia ada guna custom program for control the states of the output. Okay, aplikasi yang guna PLC yang setelah saya mendengar Encik Azhar punya talk, yang dia bagi tahu kita orang adalah paper industry, travel industry, glass industry, semua yang melibatkan industri moden sekarang ni banyak menggunakan sistem-sistem ni. Okay, minggu kedua. Alright, for minggu kedua. Okay, minggu kedua mostly kita tengok video-video daripada senior-senior lepas mengenai macam contoh daripada BND 32103 ni. Kita tengok video dia macam mana dia punya project yang menggunakan programmable HMI touchscreen LCD. Lepas tu dia punya wiring man-to-man program dengan group project application lah. Group project application diorang ada yang guna smart card system, solid distributions using conveyor belt, smart sync, multi-level parking system, automatic car wash dengan PLC based automatic cutting machine. Okay, kalau BNA 22103 pula dia buat wiring man-to-man program juga, sama macam BND tadi. Group project application dengan PLC circuit yang melibatkan industrial application lah. Contohnya automatic hand dryer, irrigation system, toll gate, roller coaster safety system, automatic surat and food elevator. Okay, for the third week, introduction for the first chapter yang first untuk self-learning pre-lab activity ni. Okay, chapter first. Okay, what is PLC? macam saya cakap tadi, PLC ia adalah programmable controller, which macam is an industrial digital computer which has been ruggedized, adapted and manufacturing control process. Okay, application of PLC: field and oil, pipeline transportation, wind turbine operation, cement manufacturing, smart factory. Semua ni application dia lah. Advantage of PLC, we know that dia lagi easy untuk kita rewrite dia punya sistem atau program for the relay system. Lepas tu dia lagi reliable, tahan lasak, easy untuk program sesuatu benda dan troubleshoot. Lepas tu PLC ni lebih fleksibel lah daripada segi komponen apa kita boleh pakai semua, dan dia sangat kuat lah, robust control lah. Okay, PLC system. Okay, PLC system ini dia ada dia punya power supply, memory unit, central processing, programming device, input device and output device. Okay. PLC works on macam cara dia operate kan. We know dia akan pergi kepada reading input, lepas tu execute dia punya logic, lepas tu dia akan writing dia punya output. Kiranya dia punya sistem ni akan continuously lah scan the process. Kiranya read input, run program, adjust output. Itu je. As we see dekat dalam ni, nampak dia punya input model, lepas tu semua processing dia, ini power supply direct 24 volt, lepas tu application dia semua, lepas tu pergi kepada output model. Macam saya cakap tadi, ni PLC operation scan process, reading input, execute logic, writing output. Memang semua ni akan jadi continuous one single loop. Okay, for the third week masih kita orang ada self learning pre-lab activity, which is kita learn how to read data sheet, semua macam pengenalan lah mengenai ombron apa yang kita akan pakai. Macam ni contoh, kita belajar cara nak tengok dia punya input dan output reference. Macam contoh lah kan, CP1E 20 CP1E kiranya adalah 20 IO. Maknanya CIO dia kita boleh guna dari input address dia 0.0 sampai 0.11. Dia punya output address dia kita boleh pakai 100 sampai 100.07. Okay, ini adalah instruction reference dia. Kita dalam PLC program tersebut, kita boleh tengok dia punya dia punya instruction lah, cara penggunaan dia, manual dia semua ada. Kiranya basically contoh kita start kan, macam mana nak guna set reset button. So ini adalah contoh cara nak dia punya simbol dan cara connection dia. So kita boleh tahu semua sekali ada dalam CX programmer. Macam NN, NLD, N0, down semua kita boleh tahu. Lepas tu kita boleh tahu dia punya function dia semua. Kita boleh baca semua daripada manual dari data sheet dia. Okay, untuk minggu keempat, dia masih dalam self-learning pre-lab activity yang dibagi kita pada minggu ketiga. Okay, dalam self-pre-lab activity ni, kita familiar dengan ombron CP1E, CPU unit. Kita understand dia punya features, CP1E, E20, SDRA. Lepas tu kita know macam mana nak read dia punya data sheet semua tu. Okay, Ini contoh macam mana kita read the model number structure. Okey, kalau kita tengok ini contoh example pertama, CP1E E20 SDR-A. Okey, CP1E dari atas ni, lepas tu dia kata E adalah nombor 1, dia punya basic model kiranya. Lepas tu 2 adalah untuk IO capacity 20, maknanya 20 IO maknanya 12 input dan 8 output. Lepas tu S3 ni adalah unit type dia, antara renewable atau normal. Okey, kalau yang macam ni renewal. Lepas tu 5 4 adalah dia punya ni satu or none, kiranya antara dia akan tulis nombor lagi ke atau tidak tu je. Kalau macam ni E20 S renewal D, maknanya tak ada, so none lah, memang tak adalah dia punya built-in R-485 port. Lepas tu nombor 6 adalah output type. Kiranya output type dia kata kalau R jenis relay output, kalau T adalah transistor output anking, atau dia T1 transistor output sourcing. Lepas tu dash A, maknanya dash A ni dia punya AC power supply lah, guna AC power supply, bukan DC power supply tu. Kalau DC power supply dia akan tulis D. Okey, ini adalah difference between normal and renewal type. Okey, kalau kita tengok daripada normal type ni, dia ada analog adjuster lah kan, dia basic model. Ini adalah renewal type. Kita boleh tengok perbezaan dua ombron yang berbeza, dua CPU yang berbeza. Okey, kalau basic model ada hub dia, USB port. While the application model built-in with USB and battery, kiranya dia ada built-in USB, lepas tu built-in battery. Lepas tu dia punya application model, battery dia set kepada CP1, lepas tu kepada battery. Lepas tu dia akan backup data kalau sekiranya ada apa kekacauan berlaku lah, tiba-tiba lost power ke power source ke apa kan, blackout ke apa, so dari situ lah. Okey, untuk fifth week kita belajar ladder diagram. Ladder diagram, kalau kita tahu ladder diagram, kita buat ladder diagram ni akan ada basic logic function, lepas tu basic logic instruction dia punya simbol-simbol dia, lepas tu dia punya instruction dia. Okey, contohnya what is a ladder diagram? Okey, ladder diagram ni macam commonly used macam untuk industrial control logic system called ladder, macam dia resemble ladder lah with two vertical bus bar dengan power supply, as many rungs yang kita gunakan untuk represent dia punya control circuit. Okey, macam ni the setting PLC use, kita pilih omron CP1E, CPU dia jenis E20, input dia dengan output dia bergantung kepada dia punya ni, macam contoh ni 20, so kita boleh guna dia punya range dia daripada situ 0 hingga 0.1, output dia 100 sampai 100.07. Dia adalah internal relay, except kita tak boleh guna CIO 0 kepada CIO 199. Ini yang tu tak boleh pakai, itu khas untuk benda lain. Okey, ini adalah basic ladder logic instruction. Okey, macam kita tengok ni, ini adalah simbol LD, no contact. Ini LD not, tapi dia normally close contact. Yang ni N series connection, ni N not series connection. Ni O parallel, kiranya dia atas bawah lah kan, O parallel connection. O not ada, maknanya salah satu ni adalah normally close contact. Okey, ini OLD or more than one serial block. Yang lagi satu ni NLD, more than one serial block, and yang bulat tu adalah output dia. Okey, ini adalah basic ladder logic function. Macam kita tengok ni simbol-simbol yang kita akan gunakan kalau sekiranya kita kena lukis litas. Ini bukan ladder diagram, dia just dia punya logic function. And O, not, NAND, no, XOR. Kiranya semua ni kita guna untuk dalam sistem kita, just cuba kita simplifikan dalam bentuk PLC punya ladder diagram. Okey, ini cycle program development. Okey, yang kita tahu macam mana kalau kita nak write satu program tu. First kali kita write, kita edit semua. Lepas tu kita terus ke error. Seterusnya sekiranya source code tu kita dapat daripada mana, kita buat sendiri ke atau improve orang lain punya ke. Lepas tu kita try compile, lepas tu linking. Sekiranya ada error, akan terus balik kepada edit balik, writing balik semua tu. Lepas tu sekiranya tak ada masalah, boleh pergi kepada machine code, pergi kepada sistem Omron tu untuk upload dia punya tu, upload and running. Sekiranya ada logical error, kita try debug apa problem dia, hardware problem ke apa kan, semua. Sebab software semua running ok, simulation semua running ok, tiba-tiba ada error kan, maknanya semua tu daripada hardware problem. So kita debugging apa problem dia. Lepas tu end of cycle, writing and editing. Kiranya benda ni akan continuously loop lah sekiranya untuk develop satu program tu untuk dia berhasil ke tak. Ok, ini adalah mnemonic code for direct. Ok, kalau dalam week 5 ni kita belajar macam mana nak tengok ladder diagram tu, kita nak tulis dia punya mnemonic code. Kalau contoh tengok rung 0, sini 0. Ok, step 0, LD, operand instruction dia LD, dia punya operand I000 itu input address dia. Ini comment adalah dia punya K, nama dia. Ok, step 1 pula dia punya output ni. Maknanya semua sekali akan jadi kosong, 1, 2, 3. Semua dia tak boleh atas bawah, dia kena kiri kepada kanan, kiri kepada kanan semua. Daripada sini nampak LD not sebab dia normally close contact. Sebab tu kita pakai LD not. Lepas tu out, ni last kali out dia. Sama juga dia macam ni, dua-dua ni adalah output. So dia tak akan tulis out. Lepas tu kita tulis dia punya comment, nama dia. Kalau ini adalah N series. N series ni dia ada dua dalam satu tu. Maknanya dia ada, contohlah kan ni A dengan B ni kan, ni adalah N sebab dia straight series. Ok, kalau macam ni, ni rung 0, step 0, LD, operand dia I002. Lepas tu dia punya comment A. Kalau B pula, nampak dia akan terus ke kanan, dia bukan terus ke bawah. Ok, ini hal lain. Hal lain nanti saya tunjuk lagi satu. Alhamdulillah. Yang ni pula step 1, 0.03 N. Sebab apa dia pakai N? Sebab dia N series, dia terus ke sebelah. Ok, lepas tu selebihnya out dia semua. Daripada situ kita boleh tengok ni continue, dia sambung, nampak. Yang ni nombor 4 ni dia pakai N0 I005. Sebab apa dia pakai tu? Sebab nampak ni normally close contact. Lepas tu kita buat semua sama. Ni sebab apa dia pakai LD0 I006? Sebab dia normally close contact. So kalau dia bukan normally close, kita boleh letak N je, tak payah letak not. Ok, yang ni adalah O parallel. Ok, kalau O parallel ni dia ada dua method yang boleh digunakan untuk write dia punya mnemonic code. Ok, ni rung 0. Ok, 0 step LD, maknanya LD tu kita boleh letak dua. Input address dia semua. Lepas tu kita akan guna OLD sebab dia akan bercantum dari sini ke sini. Ini adalah nombor 2. Ok, yang lepas tu output dia nombor 3. Okay, ini second method boleh juga. Tapi ini yang kedua method mostly saya pun pakai yang ni. Kalau saya tulis saya akan guna ni. Nampak dia LD open, lepas tu dia akan guna instruction OR sebab dia parallel. Bila parallel dia akan guna O, lepas tu out terus. Maknanya dia tak payah tambah lagi satu step untuk letak OLD. Ok, ini combination N dengan O. Maknanya macam kita tengok dia combine, nampak ada N normally close, lepas tu ada O lagi, N series lagi. Macam ni kita tengok first kali rung 0, step 0, kita letak LD not. Sebab apa kita letak LD not? Lepas sebab normally close contact. Lepas tu N dia terus N sebab sebelah ni 0, 1, 2, 3. Lepas tu OLD 4, sini 4 sebab dia parallel kan, so akan jadi 4, 5 dan 6. Okey, itu saja daripada part saya. Assalamualaikum. Daripada week 1 sampai week 5.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aikal bin Halim. Today I will explain about the activity done from week 6 to week 9. Okay, we go to the activity from week 6 to week 9. Week 6, we have the case study self-learning individual. Then week 7, we have discussed chapter 3, PLC instruction, and we have tests in next weeks. Then the week 8 is mid-semester break, and the week 9 and week 10 we have group assignment, PLC design project. There, okay. We go to the week 6 case study. Okay, we have 3 parts. Part A, Part B, and Part C. Part A is about discussion about the solution. Discuss the solution answer from the link in the week 5. Who respond the question in the link will present. And in the part B, we have video case study that lecturer will explain the video in the YouTube about the case study application. Example application that lecturer have explained in the video is about float sensor application, LED push button application, traffic light application, car application, and machine application. We will choose one of these application, and I will present from the application in the next slide. Okay, in the part C is about self-learning individual. The topic that I will discuss is about familiarization with control instruction. Then we have direct control instruction, direct control with latching instruction, and set and reset instruction, self-holding instruction, and the last one is about keep instruction. Okay, this is the case study that lecturer have explained in the video. I will choose one of the application to explain the application about the float sensor application. The sensor gives a high signal when the float level in the tank reach a certain level. The sensor is connected to an input with address I 0.00. When the float level reach the sensor. A pump should start so that the fluid is emptied out of the tank. The pump is connected to a relay output with the address Q100.00. Then we write the logical expression for F and draw the ladder diagram. First, we have to do is identify the input and the output from the question. Then the truth table, we make sure we have draw the truth table. Okay. Okay, from the question again, we must identify the input and the output from the question. From the question, we can see the input with address I equal to 100.00 is the input. Okay, input is the float sensor I equal to 0.00 and the output in the question is with the address Q 100.00 and the output is a pump Q equal to 100.00. Then we do the truth table. Float sensor, when the condition is high level, the pump will operate, and if float sensor in low condition, the pump will also in zero, no operation will set. Okay. After that, we must do the Boolean expression. Output is equal to inputs. The pump is equal to float sensor. Okay, this is the ladder diagram for float sensor application in the question. First, we have the LD, the float sensor I equal to 0.00, and we have the pump Q 100.00. The software that we have used in this programmer is we use the Omron CX programmer CP1E E20, okay, that have 20 channel, 8 for 12 for the inputs and 8 for the output. Okay, float sensor application when work online simulation. This is about the analysis and the observation from the ladder diagram. First, if I equal to 00 is false or low condition, output Q100.00 should also false. If input give the low signal, pump will not operate. Then, if input is I 0.0 is true high condition, output Q100.00 should also true. When the sensor give the logical high signal, the pump should operate. We have done for week 6 and we go to week 7 about self-learning individual. The activity in the week 7 we have topic chapter 3 PLC instruction, explanation topic familiarization with control instruction, and the last one is in the week 7 we have test 1. Okay, we go to the topic chapter 3 PLC instruction. In this week, the content is cycle of program development. Second, we have ladder logic structure. typical mistake and activity from previous. Okay, in the figure below, this figure, first we start with the writing editing, then we source code, compile linking. In the compile linking, we have syntax error, machine code, uploading, running, and debugging. In the uploading and running, we have logical error. First, writing and editing. All program tools have one or more editor. These are user interface where the program writer construct the program code. This can be a simple editor without graphical symbol and tool, or it can be editor that is equipped for programming in the graphical. First, in this figure, we can see this is normally open contact, then this is normally closed contact. This is normally open or parallel connection. This is for normally closed or parallel connection. This is normally open coil and this is normally closed coil. This is instruction that we can do keep instruction, set or reset instruction, or timer in this instruction. Okay, we go to the number 2, is compiling and linking. A compiler is the program that converts source code, machine code within the code that digital equipment such as PLC understand and can process. If the source code contains error as a result of violation of the rule, it generates error message in the compiler such as error discovered by compiler and are called syntax error. Examples of syntax error are lack of declaration of variable or call a function or subroutine that does not exist. Common to all syntax error is that they make it impossible for the CPU to execute the compiled code and is therefore necessary to edit the code in order to remove such error. This is example syntax error that always be in the home run. When we compile, we have element at rank 0, 1 or 0 is not connected. At its output, we can see no output connected in the programmable. Then number 2, we have rank 0 over point rank. We can see the output is not connected to the rank and we the syntax error. Number 3 is uploading and running. When the code is free, syntax error so that it can be compiled, the machine code can be loaded into the PLC for running. Note that many programming contains simulators so that the user can test the code without loading it into the PLC. This is Work Online Simulator. We can see this icon. When we do this icon, the online simulator will running. Then we can know by this table 0 error and 0 warning that programmer ladder diagram is corrected. Then we put the value in each of a switch. Example 0.01, we go, the value is high, give 1, then the output is connected in the run 0. Transfer from PC to PLC. This is compiled program from PC with CX programmer that uh, we have built the ladder diagram. Then we use the USB to connect it to PLC onboard CP1E and 20DRA. Okay, work online, then transfer to the PLC. Then we choose the file, program, symbol, command, and program index. Then just click OK. Then we run the mode and the file will download, and we can use the PC to the CX programmer to the CP1E PLC. We have reset in the PC ladder diagram in the PC. Then we can use the panel of PLC by the set of PC. We can see the indicator of input 0.01 is light up, and indicator of switch I0.001 is light out. Then the input also light up. This is for the switch 1. This is for the switch 2. Then the indicator will follow turn on by the switch, and from the ladder diagram work online method, we can see the light is up, then the panel also will up. Okay, we go to the debugging. Most of development tools for PLC contain a tool for troubleshooting the codes. The programmer usually use the word debugging instead of troubleshooting, and error finding tools are called debugger. Debugging a program involves hunting for and correcting error. Okay, we can see for the typical mistake in this program. To normally open contact switch is used to control the skip. If at least one the switch is turned off, the motor should start. Usually the student will draw the LD or load line, this figure, of conflict between the run signs the same address output Q100.0 on 2 core in the program. We will assume that switch 1 and switch 2, the output point is the run are off. Then the PLC will also set the output logically low. Okay, when the program is executed, the network is analyzed as I0.00 is true, therefore the output is Q1.100.00 become true. I0.01 is false, therefore Q output is 100.00 will be set false. The output will remain low even though the desired function was the output should be set high when either one of both of the input is high. When turned off, switch 1, the address 0.0 become false. Input is false, therefore Q 100.00 become false. Switch to 0.01 is true, therefore Q 100.00 will be set true. No matter whether switch 1 is off or on, the motor will reach only to the state of switch 2. To fix this simple program, we use this ladder diagram to collect the equation for control the output. Switch 2 will hold the number for the height level for condition height. If the switch 1 is on, the switch automatically the motor will on run. Okay, we go to the activity week 7. It has 5 questions. Number 1 is about direct control. A pass switch start button is used to start a monitor, and another pass switch stop button is used to stop the same motor, assuming the start button is normally open contact while stop button is normally closed contact. Draw the ladder diagram for this control circuit. First, we must identify the input and the output. The input we have 2 and the output we have 1. Start button 0.02 is the input, the stop button is 0.03 is the input, and the motor 100.01 is the output. This is ladder diagram for direct control. The start button is normally open contact, and for stop button is in normally close contact. When we online the simulation, we give the highest input to the start button, and the output will running. The in observation for this direct control instruction, in initial condition given 24 volt power supply, if the button is pressed, current flow into the ladder diagram. Indicator light up, the output will on. If start button is released, will remain due to latching system. If stop button is pressed, current will interrupt and no output will on. If stop button is released, no current will flow, the system will restart. Second, we have direct control with latching. A pass switch stop button is used to start a stop, and another pass switch stop button is used to stop the same motor. Assuming the start button is normally open contact while stop button is normally closed contact. Modify the ladder diagram in Q1 so that the motor should continue to run even though when the start button is released. This is the ladder diagram for direct control with latching. The motor will hold the height value, and the function is as a latch. For the motor, if the start button is pressed, the motor output will hold the height value from the start button. This is operation of direct control with latching when work online simulator. If we give the value 1 in the start button, the motor will hold height value and the output motor will be running. Number 3 is set and reset instruction. Modify the ladder diagram in Q2 using the set and reset instruction. In ladder diagram, start button function to set the motor, and the stop button is function to reset the whole of system for the motor. Okay, when we online simulator, we can see the set is function to start the motor, and reset is function to stop the motor. This is a function of set and reset. Set is function for turn the operand bit on when the execution condition is on and does not affect the status of operand bit when the execution condition is off. Use reset to turn off and bit that has been turned off with set. This is a bit memory for set. You can see when they turn on and the status B will remain on. When the reset, turn the operand bit off when the execution condition is on and does not affect the status of the operand bit when the execution condition is off. Use set to turn on the bit that has been turned off with reset. Two instructions and reset. We go to the scaffolding indirect control dominant off. The question is modify the ladder diagram in Q2 using self-holding indirect control dominant. This is the ladder diagram for self-holding indirect control dominant of. You can see we have start button, stop button, IR1, and IR1 with the output motor. When we give the value to the stop button, we will get the output will running. The function of this self-holding indirect control domain off is for the safety in industry that is always used in the industry in the Malaysian to provide safety in working. The last one is about keep 11 instruction. Modify the ladder diagram in Q2 using keep instruction. This is the ladder diagram for keep. We must have the start button and stop button together with keep, and the memory is connected with the motor. When we give the value to the start button, the motor will running, and we give the stop button to the motor. Okay, we go to the keep instruction. When you work online simulator, we give the high signal value to the start button. The keep will give instruction to the memory, to the motor, and the motor will be running. And if we give the stop button is high condition, the motor will not running and the system will reset. The operation of keep 11 operate like a latching relay. Used to replace normal latching, there are two inputs set and reset. Never use an input bit in a normally closed condition on the reset for keep. The input device use an AC power supply. The delay in shutting down the PLC. DC power supply relative to the AC power supply to the input device can cause the operand bit of keep 11 to be reset. This situation shown on the right. We cannot use normally close in the keep. We must use normally open to the keep, and he, this instruction will operation when the push button or RB is in normally open. Okay, in the week 8 we have the week's mid semester break that we don't have any assignment or the task or project that given by the lecturer. We go to week 9. My part is about week 9, but in the week 9 is same is together with the week 10 about the group project assignment. The function of the group assignment is we have must to selected the project title. Our group have selected the automated controller bottle filling system based on PLC. Then we have used Omron CP series CP1E CPU unit to make a ladder diagram and work online simulator. Then we have to do technical report and video presentation about the world talking about automatic controller bottle filling system based on PLC. This is our group selected the title of project automated bottle filling system using PLC. Okay, the objective of the project is analyze the PLC programming using Omron CP1A series to control automation system for automated control filling system based on PLC. Then student will be able to observe and analyze the operation of the project by using flowchart and work online simulator. Then we will be able to solve the engineering problem in PLC programming to programmable, testing and troubleshooting by using the CA programmer, and design, develop and monitor automatic bottle filling system using PLC. The safety and health precaution regulation while handling the system. First, we do not sit, stand or walk on conveyor. Follow lockout, tag out or procedure. Make sure conveyor control are operating. Keep hair, clothing, jewelry and other loose item away. Check that all conveyor guards are in a place. That is your safety and health precaution while handling that system. Then we go to the list of equipment of our project. First we have DC motor, DC pump, PLC CP1A, push button to start and stop the operation, solenoid valve operation to fill the bottle with the liquid, brushless DC motor to for moving the conveyor in front or forward or backward, pulley, bearing, infrared sensor to detect the bottle. Bell conveyor is the main of operation in this project. Its function to moving forward or backward. This is schematic diagram of our group. We have the PLC that we have set. When the push button is start here, the PLC will get the information. Then the conveyor will start running. Then in the infrared sensor will detect the bottle under the tank. the solenoid valve, the conveyor will stop and the solenoid valve will open the lid and fill in the liquid in the bottle in 7 seconds. After 7 seconds, the conveyor will start running again and the operation will, will running until the stop button is pushed to reset the whole of system automatic bottle filling system. This is the ladder diagram for PLC automatic bottle filling system. Then this online simulator, if we give the value 1 height to this, the conveyor will start running and stop, will stop running and solenoid valve will open the lid and filling the bottle with a liquid in the timer 7 seconds. Then conveyor will start running again. Infrared sensor will detect the bottle and the solenoid valve will fill the bottle in 7 seconds. After that, after 7 seconds, the conveyor will start running again. Push button is function to reset the whole system. This is a flow chart for process sequence. We define the step that is processed by PLC device. Use a flowchart method. Start. First push button is pressed, then the motor will on and conveyor belt will on and moving forward. If infrared sensor will not detect the bottle, so operation will still moving. The conveyor belt and motor will moving. If infrared sensor detect the bottle, the motor and conveyor belt will off, turn off and stop. Then solenoid valve will open the lid and fill in liquid in the bottle in 7 seconds. After 7 seconds, the motor will on, conveyor belt will on, and solenoid valve will off. Then, when we press a push stop button, the system will reset the system. The conclusion about our group project is the project present an automatic filling bottle system controlled by PLC as per the filling requirement, which has simple operation. It can fill 460 milliliter bottle in 7 seconds. That is for my part explanation about the week 6 until week 9. Putri Nazatul Iman will presented about their part from the week 10 until the final week. Thank you.
Hi, my name is Puteri Nazatul Iman binti Abdul Saad and I'm 23 years old. My metric number is CN190207. I'm taking a BNE course and I'm in SEM 2 Year 2. I'm taking the part for the end of the semester, which is near the final exam. Here are the summaries for the end of the semester. Industrial talk. We listen to the industrial talk at 8:30 p.m. until 10 p.m. and it's about the PLC and SCADA application. Based on the industrial talk, SCADA is a control system architecture comprising computers, network data communication, and graphical user interface for high-level process supervisory management, while also comprising other peripheral devices like programmable logic controllers, which is PLC, and discrete proportional integral derivative controller to interface with process plant or machinery. The use of SCADA has been considered also for management and operation of project-driven process in construction. The operator interface, which enable monitoring and the issuing of process command like controller set point change, are handled through the SCADA computer system. The subordinate operation, for example, the real-time logic control or controller calculation, are performed by network modules connected to the field sensor and actuators. Okay, this one is the example of the application of SCADA, controlling and monitoring process in real time from remote location. Furthermore, analyze and calculation of complex the process and maintain accordingly the control signal. Moreover, data acquisition, historical data logging, achieving and retrieving. In addition, trend and alarm generation and receipt management for process and chemical industry. And last but not least, the report generation. Okay, for the end of the semester, we're having a group project assignment and I'm choosing the topic which is fluid level control using programmable logic control. Okay, for the introduction, the project fluid level control using programmable logic control is designed to monitor the level of liquid in the tank. The system has an automatic pumping system attached to it as to refill the tank once liquid gets to the lower threshold while offing the pump once the liquid gets to the higher threshold. Sustainability of available water resources in many regions of the world is a non-dominant issue. This problem is quietly related to poor water allocation, inefficient use, lack of adequate and integrated water management. Water is commonly used for agriculture, industry, and domestic consumption. Therefore, efficient use and water monitoring are potential constraints for home or office water management system. Moreover, the common method of level control for home appliance is simply to start the feed pump at a low level and allow it to run until a higher water level is reached in the water tank. Okay, for the objective, the main purpose of the project is to maintain the water in a desired level to any control system. PLC is used in this project as an automation tool to reduce manual operation and get the better accuracy. Okay, we have two objectives, which is one is monitoring to control and measure the liquid level in the tank to ensure that enough material is available to complete a particular batch. To design an automatic water monitoring system, to incorporate an interactive medium between the end user and the machine, to develop controller using PLC as programming. The second one is for the safety, to prevent an industrial accident by overfilling an open container to monitor tank overfilling. And list of equipment. The first one is power supply and pump motor, solenoid valve, lamp, push button. We need two push button, which is latching push button switch and momentary push button switch. Motor, sensor, we have flow sensor and float sensor. The last one is CPIE. Okay, for the problem statement is the traditional fluid level must draw the water manually to the tank when there is no water in the tank. The problem of manual control is sometimes people turn off or turn on the valve. For the automatic water level control, if the manual float broken or damaged, all the system cannot function properly. Okay, this is the project diagram of our project for my group, and this project is designed to automatically control the pump which ensure constant reserve of water in the reservoir. This is an automatic programming that the program will auto-detect the level of the water in the reserve tank, then refill the water if the water level in it is low, while stop refilling water when the water level in the tank is high. First of all, this program have another two tanks which are user tank and overhead tank, which is operation tank, in order can smooth the process of refill the reserve tank. Okay, for the conclusion, it has been a great pleasure to work on practice and progress of PLC-based fluid control system. It provides information about many topics relevant to controlling system and equipment automation. We have learned more about water level control system. It can run automatically by the help of PLC. The great advantage of PLC-based fuel and water level control system is with maximum accuracy. Also, the system has higher reliability, small space requirement, reduced cost, and able to work as a friendly with environment. Thank you.